Hi, everybody. Today we're going to take a look at equilibrium and ice charts. So ice stands for initial concentration, changing concentration, and the equilibrium concentration, or the final concentration. So what we're going to do is we're going to take a look at how this reaction works. There's one mistake in this instead of the concentration of right here, this should say Cl2, not HCl. Okay, so just so you know, that should say Cl2, and that's where this comes from. Okay, so I have 3 molar of N2, and it's reacted with an unknown concentration of Cl2. In order to establish an equilibrium of 2.0 molar of the N2, in order to establish equilibrium, 2 molar of the N2 is used up. The KQ of this equation is 1.28. So the first thing is, and I'm just going to switch back and forth between some things here. So this is basically what we have here without anything written on it. And we're just going to switch them back and forth between. So what do we know? Well, we know that our initial concentration is 3 molar. And I know I used up, so I'm going to subtract 2 molar of my N2. What I want to find is this initial concentration of the Cl2. Okay, so first thing we're going to do is find the final equilibrium for this. So I have start with 3, I'm subtracting 2, so I'm going to have 1.0 molar left. Okay. The next thing we're going to find is the concentration, the change in concentration for both the Cl2 and the N2. That's really easy because when we look at this, the concentration is going to be the same. So if I lost 2 here, okay, proportionally I lost the same amount. And I say proportionally because you have to multiply whatever you lost by the amount of that's in front, like the, what's it called, the coefficient. So here I lost 6. Now this line is important. Here I gained 4 because these are what I'm reacting, this is what I'm using up, and this is what I'm creating. So I created 4 of the Cl3. I always subtract a reactant, add a product. Okay, so now I have -2, -6, 4. So if I go back to here, I now have this one filled out, this one filled out, and this one filled out. Next, I need to find the E right here for this. So I have 0, I added 4, I got this. So I have 4 in total. And now I have to find the E for the Cl2. We're going to use the KEQ to find that because what we know is we already know this concentration. We know this concentration. We know what the KQ is. We can then calculate what the Cl3 is. So I'm going to isolate the Cl3, and I'm going to solve for it, and I get 5.0. Now, all I got to do is figure out what minus 6 gives me 5, and it's 11. 11 minus 6 is 5. That's how we solve an ice chart. Okay, so let's do one more. So here I have a sample of S8, 12 grams of S8 solid, and it's reacted in a 2-liter flask with 30 moles or 0.3 moles of oxygen gas. 6 grams of the S8 was used up. I want to know what the KEQ for this reaction is. So first things first, we need to realize that S8 is a solid. And S8, so therefore, we don't put anything, so we do not include solids as in our reaction. Okay? So that's the first thing. We need to sort of get rid of this. We know our product is 0 because we haven't created anything yet. It hasn't started. So the first thing we're going to do is find the I for the O2. So I know it's in a 2-liter flask. I know I have 0.3 moles. So I know that I can calculate 0.15 moles of it. Now the change for the SO2 and the O2, first I have to figure out what the molar mass is. And I know that I used up 6 grams of the S8. So that means I used up 0.0234 moles of the S8. So if I take that and divide by the 2 liters and multiply it by the 8, that's the amount of moles of oxygen I used up. And I have the 8 here for the SO2, so it's the same amount that I used up there. Now I'm going to find the E, so I'm just going to take this and subtract this to find the E. I'm going to do the same thing. Now I'm adding because this is on the product side. And then I'm going to find the KQ. I only care about these two. I don't care about the S8. So I look at the concentration of the S2 divided by the concentration of the O2, product over reactant, and I get 56.2. I hope this helps you understanding. We'll go over it in class again, And if you have any questions, come see me.